Assalamualaikum and good day to all. Today I'm preparing a video for covering content on class diagram. So basically this is the content of our video, and this video will be prepared in several parts. Okay, we'll be looking at class diagram. Before this, you have experience drawing use case diagram, and you have written use case specification and also activity diagram. So the next step is to actually draw a class diagram, and you actually will be using class diagram in two phases. One is during analysis and again during design, where during design phases the class diagram will be more. Okay, so the learning objective of this video is to help you to develop class diagram. So class diagram is actually a static model of UML, whereby it's basically identifying the structure of the system, whereby you identify all the classes that we involve, okay, and the relationship between it. Okay, so a class is basically a description of a group of objects. If you have experience writing Java code, so you've been having already experiences in writing a class. So if you still remember, when you write your Java code, you have to identify the name, attributes, and also the operation. Right. So if you are trying to identify a class of student, so this is a student. Okay, you write student on top, or you draw it. This is a symbol to represent a class. Okay. Class is actually the description, and it can has many copies or many instances, right? So you have a class of Maria, or you have a class of Maria student, or you have a class representing David. Okay, within a class diagram, you need to identify the attributes. So attributes is like the data that you want the class diagram to represent. It can be in different types: integer, real number, decimal numbers. It can be Boolean, string, and so on. Right? It can be in different types, either a simple attributes, meaning that it has only a single data, or it can have ID, a unique key value, or it can be in multi-value or composite. Let's have a look. Okay, you can identify the primary key for that object, for a particular class, but you don't have to do it for all the classes, right? So you only do for the class that you think you should have a unique value, right? You can also have your attributes in terms of in a type of multi-value, meaning that attributes can have more than one value. For example, if you want to allow the students, you want to capture the students that might have more than one phone numbers, you can set it as multi-value. Or you want an attributes that able to store the value in terms of the composite attributes, meaning that one attribute can have many sub attributes. For example, the simplest form of composite attributes is for address. Okay, you want to identify street, city, state, and zip code in the form of a separate attributes. You can have a simple form of capturing the address in terms of string, right? You put everything in one long string. So another form is to make them in terms of composite attributes. If you are doing it this way, you should represent that composite attributes in its own class. Okay, the second element that you need to identify for your class diagram is the operation. Okay, what kind of processes that class can do, right? So you identify it and write it on in the third part of the class diagram. Okay, so whereby you give the name. Okay, you can specify whether it's a public or it's a private methods. You can also do it the same for the attribute, whereby you can identify it as a private by using a minus sign, or you can actually label it as public by putting plus sign, and you can label it as protected while using a hash sign. Okay. Um, so when you are identifying the classes, you will later on realize that there will be many classes, and you can actually group them together. You can classify it into 3 types, or in this slide we call it as you can label it or into several class stereotypes. Okay, so you can either label it as boundary, entity, or controller. Okay, let's have a look. When you identify classes and you realize that that class is for the interface of the system, which is meant to represent the form or a display on the screen or showing the report for that system, that can be classified as a boundary class, right? The way that you give name to this class also should reflect that it's a boundary. Normally what you can do is you can add word like panel, you can add word like page or UI, just to show that this class is actually representing boundary. Okay, depending on the software that you are using for drawing UML, it can be either this form or this form or this form, right? So if you are drawing the first form, you should label the word boundary stereotype on top. Okay. The way that we give name is like you normally add the word UI or page or panel to show that this is for boundary. And normally for boundary classes, you only have attributes. Okay, most of the time. Let's move on to the second stereotype for the class diagram. This is called entity. I think most of you, when you are drawing class diagram, you will be identifying the entity class first. So entity is used to represent the information and behavior of the application domain or the system that you want to build. For example, if it's for a student information, entity class is the student, or the course of this student course. Okay, so the way that you draw it, you can either draw it like the first one, where you add entities word to represent the stereotype, or you can draw it this way, depending on the software that you're using. Okay, for entity class, you will normally have 2 parts, the data part, the attribute part, and also the method part. Third stereotype for class diagram is called control class. So this is a class that is meant to handle control of the system. For example, class that will trigger another class in order to start. Okay, and normally the way that you give name is that you add the word manager at the back or controller, just to indicate that this is a control class. Okay, and You can label the word control to represent the stereotype, and these are the methods. Again, for control class, most of the time you only have the methods. Right, what we have covered so far, been looking at three parts of the class diagram: attribute, operation, and stereotyping. Okay, attribute itself can be in a simple form. It can either have an ID, but not all the time for the ID. It can either be in a multi-value, meaning that more than one value for that particular attribute, or composite, meaning that you can have an attribute that is composed of several sub-attributes. Okay, operation is the method that, or the processes that class is uh, offering. And because later on when you are drawing class diagram, there will be many classes, and you'll be grouping them together. You categorize them together so that it can either be in a boundary form, which is representing the interface, or control form. This is the class that handle the coordination of the classes. As later on there are many classes, there will be one class that will be handle the coordination, and the last one is the entity. Entity is the class that you normally use to manage the data.